Hello, my name is Bruce, and I'm here to tell you about the deep sea, the final frontier, an energetically differentiated ecosystem that remains a mystery to this very day.
That's right, Bruce. Did you know over 60% of our planet is covered by water more than a mile deep? The deep sea is the largest habitat on Earth and is largely unexplored. More people have traveled into space than have traveled to the deep ocean realm.
That's right, Monica. Doesn't the ocean have depths up to 11,000 meters? The deep ocean is considered to begin at roughly 200 meters.
Absolutely. Can you imagine how cold it must be? I've read that deep sea floors are between -1 and 4 degrees Celsius.
Surely that's because of light's inability to penetrate to those depths, though.
Correct again. Ocean sea floors are completely devoid of solar radiation, one of the major types of energy that affects biological systems.
Wow! These ocean floors are really energy-deprived systems. I wonder how that affects life down under.
They sure are. Life on the floor is fundamentally described by the metabolic theory of ecology, which goes on to explain the chemical and thermal energy requirements of life down below. How could you not know this?
Well, excuse me for not memorizing the research article Toward a Metabolic Theory of Ecology, written by J.H. Brown and his colleagues.
Hey Nick, I cannot believe Bruce didn't know that metabolic energy processes of the deep ocean floor are dictated by the combined effects of body size and absolute temperature. Even Amanda knows that.
Seriously? Everyone knows that there are clear and obvious trends of metabolic algorithms that deep-sea organisms exhibit. I mean, really.
That may very well be. However, though the metabolic theory of ecology links physiology with ecology and successfully predicts many allometric scaling relationships, you know as well as I do that there is controversy concerning the method in which researchers examined the mean exponent separately from the variance.
True as that may be, the study definitely can safely be used as a framework for the experiment because the study concerns the relative contributions of thermal and chemical energy.
Whatever. I'm over it anyway.
Yo, how'd you feel about that bio test, Bruce? I feel like the professor spent all that time talking about the deep ocean floor of thermal energy and then only tested us on chemical energy. What gives?
Well, Amanda, she did actually discuss chemical energy in lengthy depth. She even said explicitly that cold temperatures dictate biochemical energetics of metabolism.
I disagree. She talked a lot about how temperature, in conjunction with body size, dictates how metabolic rate progresses.
Well, I thought temperature barely affected biomass and abundance. How does it dictate metabolic rate?
The POC flux, combined with thermal energy, controls metabolic rate. However, recent studies suggest that POC chemical concentrations are actually much more influential.
The PO what?
POC. I'll explain. It stands for particulate organic carbon. Basically, this is any free-falling biological matter, also known as detritus. This matter sinks to the ocean floor and is used for food and is thus a form of energy. POC flux decreases with depth and distance from the shoreline due to the carbon matter being remineralized.
So does that mean that primary production is rare on the ocean floor?
You got it. That makes photosynthetic radiation for the biological processes of photosynthesis nearly impossible at the ocean floor, thus causing need for other sources of energy.
So does that mean that the abundance of life decreases with depth due primarily to the lack of detritus availability on the ocean floor?
We have a winner! Do you think you answered that well in the test?
Nope, definitely missed that one. My bad. At least the case study on the exam made for easy points.
Did I really just hear you say that the case study was easy? I couldn't figure out what was being talked about the entire time. Something about how dead and over life everything is at the bottom of the ocean, I don't know.
Close, but not quite, Nick. The study entitled Energetics of Life on the Deep Sea Floor was actually a succinct establishment of the energy and life that are at the ocean floor.
Clearly, I didn't understand. Would you like to extrapolate?
Well, the article goes on to explain that carbon flux, your beloved POC, is the primary curator of biological processes on the deep sea floor. However, it also emphasizes the importance of temperature on these processes as well.
Wait, what? How exactly does it affect deep sea life?
Temperature affects metabolic rate, individual lifespan, and body growth, whereas POC is a primary influence on patterns of abundance, biomass, and biodiversity. These combined effects cause a peak biodiversity at a medium level within the ocean waters.
Learning about the metabolic theory of ecology is really important since it predicts how metabolic rate controls ecological processes at all levels of organization, from individuals to the biosphere.
But do metabolic rates set the rate of resource uptake from the environment and the rate of resource allocation to survival, growth, and reproduction?
Yeah, remember all those life history attributes we studied about in class? Development rate, mortality rate, age at maturity, lifespan, and the population growth rate? Metabolic rate controls all of that.
And what about all that population ecology jazz?
Metabolic rate has a major role in that too. Everything from carrying capacity to rates of competition and predation to patterns of species diversity. And did I mention patterns of trophic dynamics? MTE rules.
So, I have a quick question for you.
Yes?
What's going to happen to all those little creatures that live in the bottom of the ocean when global climate change comes to fruition?
Unfortunately, my friend, climate change will greatly impact ecosystem availability of food and will change current temperature gradients within the ocean waters, causing a shift in the global arrangement of biological creatures.
Whoa, girl, that's crazy. I guess we should be more concerned with global warming.
Oh, please.
Ariel, listen to me. The human world, it's a mess. Life under the sea is better than anything they got up there. The seaweed is always greener in somebody else's lake. You dream about gold.